All right, let's dive right into this explainer. We're going to untangle some really common traps when writing Python scripts. We interact with input and output constantly, but it's actually incredibly easy to blur the lines between what we're asking the user, what the user actually types, and what the program finally produces.
So let's start with a crucial question. Just because you hit run and see text on the screen, does that automatically mean your code is flawless for every single scenario? Man, it is so tempting to see a program successfully finish without throwing a big red error and just assume our job is completely done.
It's super easy to think that the prompt you write is the final result, or that a running program is a perfect program. But spoiler alert, those are common myths we really need to bust today. The fact is, input and output have completely different roles in Python. Just getting the program to run without an error, that's really just step one. Running does not mean correct. And output is absolutely not automatically correct just because your program successfully executed.
Okay, let's look at the official Python documentation as our ultimate evidence file here. We'll start with the exact role of the input function. According to the built-in functions documentation, the input function specifically reads a line from input, converts it to a string, and returns that. Literally, that is its one dedicated job. Now, the official behavior of the prompt itself is actually really interesting. The docs clearly state that, and I quote, "If the prompt argument is present, it is written to standard output without a trailing new line." All this means is the prompt is merely a message written to the screen to ask for data. The prompt itself is not your program's final result. It's really just the question being asked. Now, contrast that with the print function. This one is designed exclusively to convert your objects to strings and output them to the text stream. It is built to produce your final visible result on the screen, which is completely separate from the act of gathering data. This brilliantly illustrates how they have totally distinct roles. You can think of input as the microphone, asking a question and reading a line, while print is more like the printer, converting your objects to strings and producing your actual final result. They are completely distinct tools for completely distinct jobs. All right. Now that we have our evidence straight from the official Python documentation, let's put on our code detective hats. We're going to examine a working example straight from the Python tutorial just to see these distinct roles in action. So, if we use the code s equals input with a little arrow prompt, we actually see three distinct things happen in order. First, the prompt arrow appears, asking for info. Second, the user types the entered value, which in the documentation's example is Monty Python's Flying Circus. And finally, the program can print that output as a string. Notice how we meticulously separated the prompt from the typed value and the final output. That's because they are three completely different pieces of the puzzle, and they cannot be swapped. A prompt asks the question, an entered value is what the user actually provides, and a printed output is what the program evaluates and returns. One definitely does not equal the other. But here is the real trap. Let's say we've run our script once. We type an input, and it produces an output. Does that one single successful run prove our logic handles, everything perfectly? No, because an observed result just tells us what happened during that specific single run. It always has to be checked against the broader intended task. Basically, just because the code didn't break doesn't mean it did what it was supposed to do for every possible situation. Let's transfer this concept to a brand new situation. Imagine a script asks for an integer and then uses an if statement to check if it's negative, 0, single, or more. We start with x equals int of input, passing in the prompt, please enter an integer, and that's followed by our conditional branches. Looking at this code, take a second. Can you identify exactly what the prompt is, what the user's input value would be, and what the final output is based on the tutorial's example? Really think about it. Okay, let's break it down and see how you did. The prompt, the actual question being asked, is please enter an integer. The input is the entered value from the user, which in this case is 42. And because 42 drops down to the else clause in our code, the output is the printed word more. So here's the crucial point. If we test this by entering 42 and the output says more, does that one successful run prove the program handles negative numbers or 0 correctly? It definitely doesn't. Testing just the number 42 entirely skips the code paths for negative numbers and 0. It just goes to show that just because it ran once doesn't mean it's fully correct. You literally haven't proven that those other branches of code are actually bug-free. So,
Remember our ultimate takeaway from this explainer? You must always test your inputs, read your outputs carefully, and check every result against the intended task. Ask yourself, are you actually testing every path in your code, or did you just successfully print the prompt? Keep that question echoing in your head the next time you hit run.